Myself, Dr. Harmeet Singh, Assistant Professor, SC Department, City University. So in this lecture, we will study about sensor and instrumentation. So the main objective of this video is to understand about the different measuring instruments and to know more about the sensors which we can use in the industry or at home. So first of all, if we talk about the basic of measurements, the instruments which we use to measure any quantity are called measuring instruments. So in this video, we will study about 4 different electronic instruments like voltmeter, ammeter, ohmmeter and multimeter. So first we will start from voltmeter, and the name suggests it's used to measure the voltage across any 2 points of an electric circuits. And there are 2 kinds of voltmeters, DC voltmeters and AC voltmeter. So DC voltmeter measure the DC voltage across any 2 points of an electronic circuits, and whereas AC voltmeter is used to measure the AC voltage across any 2 points of an electronic circuit. And if you see this image, we have a DC voltmeter and its range is from 0 to 10 volt, and you can just measure from 0 to 10 voltage. After that, we can talk about ammeter. The name suggests it's used to measure the current flowing through any 2 points of an electric circuit, and there are 2 kinds of ammeters, DC ammeter and AC ammeter. So DC ammeter measure the DC current that flows through any 2 points of an electronic circuit, and whereas AC it used to measure the current through any 2 points of an electronic circuit. And this image you can see it's a AC ampere meter. So it's from 0 to 100 amperes. So basically its range is from 0 to 100 amperes. Next we will talk about the ohm meter. Name suggests again it's used to measure the value of the resistance between any 2 points of electronic circuits. And again in this also we have 2 kinds of ohm meter. First is the series ohm meter and second is the shunt ohm meter. So in series, name suggests that it is used to measure the unknown resistance. In this, if you want to measure the unknown resistance, you have to connect in series with the ohm meter. That's why we called it a series ohm meter, and it is useful for measuring high values of resistance. And second, we have the shunt time ohm meter. And this, if you want to find out the unknown resistor, you have to connect that resistance in parallel, and it is used full for measuring the low values of the resistance. And in this example, you will see we have an ohm meter from 0 to 100 ohm. Shunt ohm meter means the range is from 0 to 100 ohm. But nowadays we are using multimeters. In multimeters, if you want to measure the current, voltage or resistance, so there is a single device which we call as a multimeter, and you can measure all these things. In this image you can see it's an analog one, but nowadays we are using the digital one. You can use for AC voltage, you can use for the DC voltage, and this is the equipments that we are using nowadays. Now we will talk about the performance characteristics of these instruments. I will talk about the sensor also later in this video, but we are going to use the same characteristics for the sensors and for this measuring instruments. And if we talk about in short sense what is sensor, sensor is something that senses from the environment or that converts the non-electrical signal into electrical signal. So these characteristics are like this characteristics which we can use to find the performance of our instrument. So there are 2 types of characteristics like static and dynamic. So if we talk about the static characteristics, so the characteristics of the quantities or the parameters measuring instrument that do not vary with respect to time, or we can say that varies very slowly with respect to time. That's why the name is static characteristic. And we have different parameters in that. First we have accuracy, precision, sensitivity, resolution, static error, dead zone, hysteresis and drift. So first of all we will study about the accuracy. So accuracy of any measuring instrument or a sensor. So the algebraic difference between the indicated value of an instrument, which we called as AI, and the true value, that is AAT, is known as accuracy. So mathematically we can say that the accuracy is AI minus AT. And the term accuracy signifies that how much the indicated value of an instrument it's closer to the true value. So if we just take an example, just imagine your weight is 88 kg and your weighing machine tells that it's 87. So we can say that the accuracy is plus minus 1 kg. And if you want to see this also, you can take any instruments like vernier caliper or any digital measuring device like something. So you can see that it's always written that the accuracy is plus minus 1 or plus minus 0.1 millimeter or something. Means it will give you a reading, it's closer to the actual value, but there is some accuracy, means there is a chance of some error. After that, the second parameter is the precision. So if the instrument, or we can say that if any sensor indicates the same repeated value, it means that that device has a high precision. So let's take an example. So I will just talk about 4 examples. So we have this circle. Again we will take 4 circles. So first of all, we will talk about when we have high accuracy. I will just change the color of the pen. So if we just first condition is that when we have high accuracy but low precision. So this is, we have high accuracy but we have low precision, means we are not getting the repeated value. Example, if you are using the same weighing machine, so you are getting the actual weight is 88 kg, but you are getting 87, 87.5, 89. So means this is accurate, but you are not getting the precise value. So it means that the accuracy high but precision is very low. And when we talk about high precision is there but accuracy is not there, so just see. So we got these 4 readings. It means your values are 92, 92.1, 92.3, 92.5. Means it's precise, means you are getting the same values again and again, but accuracy is very low. And third condition is that when we have both things together, accuracy and precision. So just imagine we have 4 points together at the same, means it's quite accurate and precise. And last is that when we have no accuracy and no precision. So these are the 4 conditions. So this is the case when you're getting 60 kg, 70 kg, 90 kg. So it's not precise, you're not getting the values which should be like 88 kg, and it's not accurate. And after that we have static error. So the difference between the true value, that is 80, of the quantity that does not vary with respect to time, and the indicated value of instrument, which is AI, is known as static error. So mathematically we can say that ES, that is static error, is equal to 80 minus AI. And if you want to just check it in terms of percentage, so you have to use ES divided by 80, means the value of the instrument, basically the actual value multiplied by 100. The next term is very important in terms of sensors on instrument, is sensitivity and resolution. So first we will talk about the sensitivity. So the ratio of the change in the output, which is delta A out, of an instrument for any given change in the input, that is delta A in, that is to be measured, is called sensitivity. Mathematically we can say that delta A out divided by delta in. So if it terms in, if we talk about in the normal terms, it's something like how sensitive is your instrument or how sensitive is your sensor. So the term sensitivity signifies the smallest change in the measurable input that is required for the instrument to respond. And the resolution, it's if the output of the instrument will change only when there is a specific increment of the input, then that increment is called resolution. So basically, what's the difference between the resolution and the sensitivity? So the resolution is the smallest portion of the signal that can be observed. On the other hand, the sensitivity is the smallest portion of the signal that can be detected. Let's take an example. If we say that, okay, my temperature sensor is very sensitive, means it will detect the small change, because in some application, if we talk about, we need more sensitive sensor, in some it should not be our priority. If we take an example of any chemical reaction, in that case our sensor should be more sensitive, because we want that it should take a decision when there is a change in 0.1 degree Celsius. But in some other case, if we talking about something like greenhouse effect, in which sensitivity is not an issue, if there is a change in 1 degree Celsius or 2 degrees Celsius, means it should not detect that much. Yeah, but if it's a change of 5 degree or 10 degree, then it should be detected. So this is the sensitivity, and resolution is the smallest portion of the signal that can be observed. So we will do some numericals in which it will be cleared later in this video. After that, the another static parameter is the dead zone. So for the largest range of the value of a measured variable to which the instrument does not respond. So the dead zone occurs when more often due to static friction of an instrument. So if we talking about the example of the dead zone, due to static friction, a control valve does not open even there is a large opening signal from the controller. Then we have hysteresis. So it's a phenomena that illustrate the different output effect when loading and unloading. So it means that when are you using some instrument and you are getting some increasing value of the sensor, and again when you are getting the decreasing value of sensor, the values are different. So they are not same, but it should be same, but it's not same in this phenomena. So we call this as a hysteresis. Then we have drift. So drift is an undesirable changes in the output of a measured value over a period of time, which is unrelated to the changes in the output, operating condition and load. So the reasons may be the environmental factors such as mechanical vibration, changes in temperature, electric field, magnetic field, or something different. We can say that the example, if we take about like you are using accelerometer, the sensor inside or outside, maybe the temperature difference is large, like outside it should be like minus 50 or minus 60 and inside it's in like 10 or 20 degrees Celsius, so you will get different readings. So now we will just study two numericals. So you will be more clear about the resolution. And first you can see, determine the resolution of a voltmeter which has a range readout scale with 100 divisions and a full scale reading of 100 volt. So if 1/10 of a scale division can be read, certainly determine the resolution of the voltmeter. So basically in this numerical you have to find out the resolution of the voltmeter. So it's already given that the 100 scale division is equal to 100 voltage. So means when you are going to find out the one scale division, it's 100 by 100, which is equal to 1 volt. And it's already written that if 1/10 of the scale division can be read, so means resolution is equal to 1 volt divided by 1 by 1/10. So it means the resolution is 0.1 volt. It means that the smallest portion of the signal that can be observed is 0.1 volt. And the second numerical you can say is like it's a transducer, means a sensor measure a range of 0 to 200 Newton force with a resolution of 0.20% of full scale. So what is the smallest change in the force which can be measured by the transducer? So it's, you can see the solution, it's very easy. You can see the range of the force is 0 to 200 Newton. So means the range is 0 minus 200 Newton. The resolution is already given, but it's in percentage, that 0.20%. The smallest change which we can measure is 200 multiplied by 0.20 divided by 100, because it's in the percentage, and the smallest change which we can measure using this instrument is 0.4 Newton. So this is a very easy numerical which you will get the knowledge about the resolution and the smallest change. After that we have dynamics characteristic. We already covered the static characteristics. So dynamic characteristics are the characteristics which vary quickly with respect to time. So that's why we called it dynamic characteristic. So we are only 4 characteristics. First is the speed of response, dynamic error, fidelity and lag. So first, speed of response. The speed at which the instrument responds whenever there is a change in the quantity to be measured is called speed of response. So it indicates how fast is the instrument. So I already told you about sometimes we need an instrument that will give you high speed of response, and sometimes it's not that much necessary in the application. So in this, speed of response will tell you how fast is your instrument. It depends upon the application, whether you are using for launch of a rocket, whether you are going to use in the greenhouse effect. So it depends. So before buying an instrument or sensor, you have to look for all these characteristics. Then we have lag. So the amount of delay present in the response of an instrument whenever there is a change in the quantity to be measured, it's called lag. So sometimes you will see when you measure something, so there is a lag. maybe you are already measured the temperature like 20 degrees Celsius, but you are getting that value after 5 minutes or 6 minutes. So we call this as a lag. Then dynamic error, the difference between the true value, which is AT of a quantity that varies with respect to time, and the indicated value on the instrument, that is AI, it's called dynamic error. We use the notation ET. Then fidelity, the degree to which instrument indicates changes the measured value without any dynamic error is called the fidelity. So these are the dynamic characteristics we already covered. Now the next part is very important in terms if you are going to measure or if you are going to use any sensor for your application, the error analysis. Because you should be aware about the errors you will get using any device or sensors and how to correct that errors. So the errors which occur during measurements are known as measurement errors. So we can classify these errors into three types: gross error, random error, and systematic error. So first, the gross error. So the error which occur due to lack of experience of the observer while taking any observation are called gross error. So there are many chances that when the observer is not experienced, so you will get these kind of errors, and sometimes it's because of the improper instrument. So how you can improve this error? So choose the best suitable instrument based upon the range to be used and note down the reading carefully. So just imagine if you are going to measure something like Werner caliper and you want to measure 170 millimeter and you were not aware about that thing, that the Werner caliper that you were going to use is of from 0 to 160 millimeter. So it's because of the instrument, and because the observer was not experienced, so you will get these kind of error. And just imagine you are going to use for some application which is going to be very expensive one, so you have to check all these error before, all the characteristics like the range of the instrument before. The next is the systematic errors. So if the instrument produces an error which is of constant uniform deviation during its operation, it's called systematic errors. So the errors are divided into three types: instrumental error. These types of error occur due to shortcomings of instrument and the loading effect. Environmental error, it's occur because there is a change in the temperature or the pressure. Then observational error, which is occur due to the observer taking the meter reading. So if we take an example of this systematic error, just imagine you are taking reading inside your room and the temperature is 10 degrees Celsius, and the same sensor you are going to use outside and the temperature may be like minus 20 or minus 6. So you will get different reading. And the best thing about this error is that you can easily correct this error because these are uniform, constant uniform error. There are some offset that you have to be deduct, or maybe you have to add into your reading. Just take an example: if there is a weighing machine, your weight is, just imagine, 88 kg and it's giving 90 kg, and there's another person having weight 68 kg and it's giving 70 kg. So we know that it's error, systematic error, there is an offset of 2 kg. So what you will do at the end, just minus or subtract the offset. Then after that we have random error. So random error, the error which occur because there is no proper reason for this, that's why we call it as a random error. So how we can improve this random error? First of all, you have to take more number of readings by different observers, and second, you have to do the analysis of that reading. The example is that just imagine you are using a sensor and you are not getting the same values that you want to expect. So what you can do? So take as much as reading and change the observer. So you will get to know about that, is there any offset in this, or maybe there is an environmental condition, because it's a random error, so you are not aware about the condition. So second is that we can use a statistical analysis. So you can use the mean of your signal, median, variance, deviation, standard deviation. So these are the common errors, and the best thing about these errors that if you study this in advance before buying any instrument or any sensor, so you can correct these errors, because these are the errors you will definitely going to get. Just imagine if the application is greenhouse effect, greenhouse, so in which you are going to use a temperature sensor. So you are going to get some errors like environmental error because the temperature changes or something, the observer is different. So you have to find out whether it's a random error, a systematic error, or gross error. So now we will just talk a little bit about the transducer. Okay, so it's like a component that converts one form of energy into another form, and the transducer which convert non-electrical form of energy into electrical energy is known as electrical transducer. And after that we have two kinds of transducers, active transducers and passive. So active transducer, which can produce one of the electrical quantities such as voltage and current, is known as active transducer. It is also known as self-generating transducer. So it does not require any external power supply. So these kind of transducer does not require any external power supply. You will just get the change in voltage or current. The example is like piezoelectric transducer, photoelectric and thermal. So piezoelectric sensor, it's kind of a sensor in which you can use this as a sensor also and as actuator also. Then we have a passive transducer. The transducer which cannot produce the electric quantities such as voltage and current is known as passive transducers, but it produces the variation in the passive elements like resistor, inductor and capacitor. So examples are like resistor, inductive and capacitive transducers. Thank you so much.